So, welcome to today's lesson based on the science teacher. Today we are looking at cations. Now, before we delve straight into cations, I want us to know that we are basically talking about ions, and ions are on two different types. Others are called cations, others are called anions or anion. So, the difference is cations are positively charged, then anion negatively charged, as you can see. So negatively charged and positively charged. Okay, so cations, positive charged, anions or anions, they are negatively charged, right? So basically, an ion is a charged particle. When you say an ion, you have not specified whether you're talking about something that is positively charged or something that is negatively charged. It's just an ion. All right, great. So cations are positively charged. Anions or anion, don't know how you'd love to pronounce them, but they are negatively charged. All right, so examples of cations: elements such as sodium, lithium, magnesium, and so on. All metals form what? Form cations. All metals form cations. So this means that all metals form positively charged ions. All right, good. So these cations can be divided into three categories. All right, and the first category is what we call monovalent. Okay, so monovalent, mono means one, so valent is basically referring to the valency, right? The combining power, the number of electrons the particular element has got to lose, being a metal in this case, for it to be stable. All right, so monovalent cations are all those in group 1. In group 1. So group 1 elements or metals are all monovalent cations. They form monovalent cations. All right, great. So the other category, the second category, is divalent. Divalent cations. Di means 2. Okay, valent again referring to the valency, the number of electrons this particular metal will have to lose for it to be stable. So the combining power, so to say. And divalent cations are formed by elements or metals in group 2 of the periodic table. So that includes calcium, magnesium, and the likes. So let's go to the third category. The third category is trivalent. Trivalent, right? So tri, 3. Okay, simple, right? Tri, 3, valent referring to the valence, the combining power. And when you say combining power, we mean the number of electrons this particular element will have to lose, being since it's a metal. And for non-metals will mean the number of electrons that it has to gain for it to be stable. All right, so let's start with examples of monovalent cations. All right, so the first example of monovalent cation, the first simple example that we are going to look at is that of sodium. All right, so we're going to start by looking at neutral sodium atom. The neutral sodium atom, if you check the periodic table, that's Na, and it is the mass number of 23 and the atomic number of 11. In one of the videos, we talked about this, so we have no much problems here. We know the number of electrons here, we know the number of protons, we know the number of neutrons. So How many electrons? This number will represent the number of electrons. How many protons? Protons, since it's neutral, electrically neutral, it means the number of protons is equal to the number of electrons. Okay, so for us to know the number of neutrons, of course, we are going to say the mass number 23 minus the atomic number, and we are going to get a 12. So which means here we have a 12. All right, so this is the neutral sodium atom. All right, neutral sodium atom, which means it's not positive, it's not negative. Of course, sodium being a metal is not positive yet, it's just neutral. Now, when it becomes neutral, what it means is the number of protons is going to be more than the number of electrons. All right, so electrons are going to be fewer as compared to protons. Hence, since we know that electrons are negatively charged and protons are positively charged, so we are saying the number of positive charges is going to be greater than the number of negative charges. Hence, it's going to be positive. All right, so if we had to write this, the stable atom of sodium here, we are going to have the following. We're going to have this sodium, and we're going to have a plus here showing that it's now an ion, a cation. So electrons, protons, and neutrons are going to be slightly different as compared to the neutral atom of sodium. So electrons this time around, here we had how many electrons? We had 11. All right, and this atom is a monovalent cation former. So what happens is the number of electrons is going to be 10. The number of protons is going to remain 11, and the number of neutrons is also going to remain 12. What? Where has one gone? One has been donated. All right, metals give out electrons. Metals lose electrons in order for them to remain stable. Let me show you something. Let me just remind you something. If we had to draw the electronic structure of this sodium of ours, let me just write it here again: 23 mass number and 11 atomic number. We are first writing 2 electrons here. In the second shell, we write 1, 2, 3, 4, 5, 6, 7, 8. Okay. If we include the 9, 8, if we say 2 plus 8 giving us 10 plus 1, 11, this is a neutral. This is a neutral atom of sodium. This is a neutral atom. All right. But in cases where we have the outermost shell gone due to the fact that it has donated that electron to another element, a non-metal, we have this as a positively charged ion, and we call it a cation. So if we had to count the number of electrons now, they are what? 10. Why? Because one has been donated to a non-metal. All right, great. So that's about monovalent cations. Let's go to divalent. Divalent, the difference is just 2. So since we're saying divalent, this time around we are going to use an atom or an element that is coming from group 2. All right, so that's because we have specified, we are saying divalent cations. If we say divalent anions, it means we have to pick an non-metal that has the valence of 2. So in this case, let's use magnesium. Let's use magnesium, and it's 24, 12 here. So if we had to draw the structure, we know that we are going to have 2 electrons in the first shell. We're going to have 8 in the next shell. If you are behind on this topic, you can visit one of the videos written the periodic table. We covered this. So in the outermost shell, we are going to have 2 electrons. I hope these are looking like electrons. Yeah, we're going to have 2 electrons. All right. So for this to become stable, it means this shell here is going to be removed. And what does that mean? It means it is no longer a neutral magnesium atom, but a what? But a cation. All right. So this structure that we have just written here has less electrons as compared to the structure that has the 2 electrons in the outermost shell. All right. So to just show it nicely, allow me to say magnesium, okay, with 24 mass, atomic number, and 24 the mass number, though not useful in this case. We are going to have protons, electrons, and neutrons here, just like we did with sodium. Protons are 12 in a neutral atom of magnesium. Electrons are 12. Okay. Neutrons are 24 minus 12, and we get a 12. All right. So this is for a neutral substance, for a neutral what? Atom of magnesium. All right. Now let's write the same format yet for the stable one. So what that means is we have electrons this time around, protons and neutrons different, slightly different though. Protons are going to remain 12, okay? Neutrons are going to remain 12, but for electrons, remember, 2 electrons from the outermost shell have been donated to a non-metal, okay, and specified though. So we're going to say 12 minus 2, that's going to be 10. All right. So if we look, these are negatively charged and these protons are positively charged. So the number of positively charged particles are more than the number of negatively charged particles. Hence, that magnesium metal is positive. It's a cation. Okay. Okay. So the third example is that of a trivalent cation. So in this case, we can use aluminium, and we know that the mass number is 27 and the atomic number is 13. All right. So let's see number of electrons, the number of protons, and the number of neutrons. What we are going to have here is that electrons are going to be 13, this number. Protons are going to be 13 because this is a neutral aluminium atom. It's neither positive nor negatively charged. So it's not an ion yet. It's not a cation yet. So the number of protons and neutrons are equal, and which makes it neutral. So the neutrons are going to be 27 minus 13. That gives us 14. All right. So when it gets stable, this number here, the number of electrons, reduces because 3 electrons from 13 are going to be lost. I hope we understand it. So what happens is from the same aluminium, 27 and 13, what we are going to have is that electrons, protons, and neutrons are going to be a bit different, right? So neutrons are going to remain 14 still. Protons are still going to be 13, but electrons are going to be 10. All right, are going to be 10. Why? Because it's 13 minus 3, trivalent. All right. So what this means, or if we had to show it, in the first shell of aluminum, we have 2 electrons. In the second shell, we have 8 electrons. Okay. In the last shell, we have how many? We have 3. We have 3. Now the valence of aluminum is 3, so which means it loses 3 electrons, and so that will mean this shell should completely disappear. All right, and when this electron disappears, what we are going to have is simply this. All right, with this included, with this included. All right, so this is now a cation, and it's a trivalent cation, very different from the neutral atom of aluminum. All right, so here's what I want to show you for each example that we have done so far. It's important to know this. We used aluminum, excuse me, we used sodium, we used magnesium, we used aluminum, right? So for the cations that we're talking about, sodium becomes sodium minus an electron. Then what do we have? Sodium minus electron, we have sodium with a positive charge. All right, this is just a simple equation. For magnesium, also magnesium minus, we said it's a divalent. For this one is monovalent, that's why it's just an electron. For this is divalent, so minus 2 electrons. And what do we have? We have magnesium with a positive charge. Okay, for aluminium also, aluminium, we said aluminium is the trivalent cation, forms a trivalent cation. So 3 minus 3 electrons, aluminium minus 3 electrons. What do we have? We have aluminium as this. All right, so this is very important. Flashback. So see, this is the equation. Sodium minus 1 electron, we have sodium plus, which means sodium positive. This is an ion. This is a neutral atom of sodium, neutral atom of magnesium, neutral atom of aluminum. This is the trivalent cation. This is the divalent cation, and this is the monovalent cation. So this is all about cations that we can cover for today. Just flashback in case you missed something as you are copying. I know you can still pause the video and learn. If you have any question, feel free to ask. You can WhatsApp or Facebook or email. So thank you very much for joining, and I hope we've learned together, because that's the OM.